Hello friends, this is a continuation video to illustrate basic rules for solving linear inequations. Now, in this video, we will consider rule 4, which regards taking reciprocal while solving linear inequations. Now, first we try to understand the logic behind this rule, then I will list the rule. Now, if we consider two numbers 4 and 5, it is obvious that 4 is less than 5. Now, what if we consider their reciprocals 1 upon 4 and 1 upon 5? We can easily see that 1 upon 4 is greater than 1 upon 5. So this simple example illustrates what should happen while taking reciprocal on both sides of inequations. So if x is greater than y, we can say 1 by x will be less than 1 by y. Means if we take reciprocal, sign of inequality should reverse. However, we have to be careful regarding sign of quantities on both the sides. Suppose we consider two numbers -3 and 2. -3 is clearly less than 2. Now what happens if I take the reciprocals? Left side is -1 by 3, right side is 1 by 2. Now in this situation, since the sign of quantities on both sides was different, so even after taking the reciprocal, the sign of inequality remains unchanged. So just be careful when taking the reciprocals. Sign of inequality will reverse if and only if quantities on both sides have same sign. If the signs are different, then sign of inequality remains unchanged. Now let us consider an example for applying this rule. This is a simple example to illustrate various steps that need to be applied while solving the equations. Now, as before, we can either transfer 2 to the right or this factor to the right. I find more comfortable transferring this factor. So, just a matter of personal choice. 5 comes to the left, its sign changes. Variable factor goes to the right, its sign also changes. At this stage, I will take the reciprocal, take reciprocals. Now, left side is certain that it is a negative number. Right side, I have a bit of dilemma. Now, 4x minus 5 can be positive as well as a negative quantity. Then first I will assume that 4x minus 5 is a positive quantity, which implies x is greater than 5 by 4. Now, with this assumption, if I take the reciprocal on both the sides, the sign of inequality should remain unchanged. So I will get minus 1 upon 3 is less than 4x minus 5 upon 3. Now I multiply both sides by 3 to arrive at this step, then transposition. Now I can divide both sides by 4. Now x greater than 1 is dependent upon the fact that 4x minus 5 must be greater than 0. Now this is the first case for solving this linear inequality. So to represent the solution on the number line with the assumption that x is greater than 5 by 4, inequality gives me additional result, that is x must be greater than 1. So I will represent both the results on the number line. So basic assumption in this case says x is greater than 5 by 4, which means this portion of the number line, and then inequality says x should also be greater than 1. In this situation, since I have to satisfy both the conditions simultaneously, so I will identify that region of the number line where both the solutions are present, which is x greater than 5 by 4. Now I will consider second case when I assume that 4x minus 5 is less than 0. In the second case, I assume 4x minus 5 to be less than 0, which implies x is less than 5 by 4. In this case, right side becomes negative. So both the sides then are negative, and if I take the reciprocal, now the sign of inequality should reverse. So taking reciprocals, I reverse the sign. Now 3 can be transferred to the left. Five to the right gives me x is less than 1. X is less than 1, and this result I am arriving on the basis of assumption that x should also be less than 5 by 4. So once again, using the number line, I can find out the values of x which satisfy both the inequations x less than 1 and x less than 5 by 4. So in this case, solution is x must be less than 1. Now these two cases are either or cases, either first case solution or second case solution. Both of them satisfy the given inequality. So our final answer for this inequality will be x is less than 1 or x is greater than 5 by 4. On the number line, in interval notation, we can represent the same solution as x belongs to its union with I hope you already understand the representation of various types of intervals. So this is the final solution for this inequality. In the next video, I will illustrate another method for solving the same inequality. Thanks for watching.